Hey guys, today we will talk about installing Java programs and libraries, and this will going to conclude our series of videos on installations. Let's start with the concept of Java virtual machine. An interesting fact about Java executables is, unlike other executables, which are typically platform dependent and run only on the architecture that they have been compiled for, Java executables are 100% platform independent. Java classes run in Windows as well as on Unix. In other words, they are binary compatible. And this is a functionality provided because of the Java Virtual Machine. The Java Virtual Machine, or JVM for short, has two primary functions. One is to allow the Java programs to run on any device or operating system, known as write once, run anywhere principle. And two is to manage and optimize program memory. So it provides an interface and makes the programs running on it independent from the architectural details by handling those itself. When Java was first released in 90s, all computer programs were written for a specific operating software, and program memory was managed by the software developer. So the JVM was a big revolution at the time. As a consequence, Java libraries don't really need to be installed like other applications. They are typically distributed as jar files, short for Java Archive. They are binary files and they are able to run in every platform thanks to the Java Virtual Machine. So we don't need to compile them. All you need to do is generally to download the relevant jar files in a specific location and add this path to your Java class path environment variable. Class path is the environment variable that tells the Java Virtual Machine where to look for classes. Uh, should it require to reach one of those classes? We will see about this shortly. Let's start by installing Java environment. You can install the Java Development Kit, abbreviated as JDK, with the following command in Linux. The Java Development Kit includes the tools to develop Java programs, such as the Java compiler JVAC. As a side note, if you only want to be able to run Java software, then you can install a more lightweight version that doesn't include these developer tools, which is called the Java Runtime Environment, or JRE, using sudo apt-get install default JRE. But we will need the Java compiler for this video, so let's go for the full JDK version. In general, there is no disadvantage to installing JDK instead of JRE, except for the larger installation size. In macOS, the equivalent command is going to be first arranging the repository for brew, and then for Java Development Kit version 8. If you are working in the university servers, then you will not have the sudo rights to install these programs, but don't worry, the Java Development Kit is already available on the university server, so you will be able to use the commands Java and JAVAC. So after this installation, these two commands must be available for you. First, the Java runtime command, and then the JAVAC compiler. So in setting up the Java applications, you generally need four environment variables. One of these is maybe opening my bash RC. One of these is path, the standard one that we already know. This path should include the locations for Java compiler JAVAC and Java, so that when I run them from my command line, they should be in a findable location. We can check their locations using with JAVAC and with Java, and they are under USRBN, which is typically already included in path. The second one is the class path. The class path is a list of directories that include Java class files and jar files. The Java compiler and Java runtime search through the class path entries for finding the classes referred in your program. Finally, Java Home and GRE Home, they keep the locations of Java Development Kit JDK and Java Runtime Environment GRE respectively, so we can export them, for example, using so Java Home should point to your JDK home directory. We can look for this directory using the command locate, but don't forget to update your database beforehand. In Linux, you are going to use sudo update db, and in if you are working on the university servers, you you can skip this step. The step, the Java would have been installed quite some time ago, so it will already be in the database. And in the Mac case, you can use this update db script. Now we can search for example, JDK, and in a Mac installation it will be this folder under library Java virtual machines, and then the related Java version, then contents, and home is also going to be included in the path. So we can add this part to here. We don't need to set GRE home because we are using Java Development Kit instead of Java Runtime Environment. Runtime environment. So this is more like an optional parameter when we don't have this one set. I'm going to write this one. I'm going to exit. So let's now talk a bit about class path. This is a bit more tricky. The class path, well, first of all, it holds the locations to jar files. So if you want to use a third-party Java package, you need to place the distributed jar file in a location that is available to the Java compiler and Java runtime through this class path environment variable. The second thing that Java path holds is the places for the Java classes that you want to run. So when you try to run a Java class, first the standard Java directories are searched, then the user specified classes are searched, and these are in order. First, Java searches the current working directory. Then the entries in the class path environment variable are searched, and these override what has been found in the working directory. Then entries that you give to Java with the argument cp or class path are searched, and this overrides the contents of the class path environment variable. And finally, if you are using the jar option, then the paths given with this jar option are used, and this overrides all of the above. So in general, this order is troublesome and important to keep in mind. I generally use my class path environment variable to set the locations of everything. But one suggestion that the Java people say, if you are developing extensively in Java, then they promote using the class path option, so that you can customize the paths for each of your applications separately, instead of setting a permanent class path environment for all the Java applications. I don't really develop in Java myself, rather I only use it for specific applications, and therefore I don't really see a need to keep nodes for different class paths for every different application and dig them up when I need to run them. Instead, I just dump all the related locations in my class path. But this is ultimately your decision. I think it depends on how much and how professionally you are going to use your Java. But it's important to know that if, for example, you both set a class path and use the CP option, then the CP is going to override class path, jar is going to override everything, and setting up the class path environment variable is going to override the default search directory, which is the current working directory. So this kind of order can be important to find. If at some point Java runtime gives you an error of could not find or load main class for newer Java virtual machine versions, or Java lang no class def found error for the older versions, then this means that well, basically Java couldn't find your file, and this means the file is not successfully added to the class path, and in that case you should go and check the class path. Also, setting the class path is a bit different for jar files and for class files. So in general, if you are using a jar file, then every jar file should be listed separately and explicitly in the class path. If you are using class files, then the class path should only point to the directory that holds the class files. This was a lot of talk, so let's download an example and from it try to go one by applying everything. First, let's go to this library, Google JSON. This is a library for using the JSON format for Java by Google. We can go this and, well, here there is the download instructions. We will talk about this Maven in a bit, but let's for now do the basic jar download case, which is doable for simple libraries like this one. So I went to the download for the jar file, and in the downloads I will find the jar, then week 6, and okay, I already have a Java there here. Okay, I already have a jar. So basically, well, what I'm doing is I'm copying my downloaded JSON to under the jars folder, and the full path will be now this one for this jar. Now I want to be able to use this jar, and the way I use it is, for example, if I go here, clear, so I will use that library in this very simple code. This is how we import the libraries, and this path is really important for Java. So once I add the path to this jar file, then as soon as it looks into this jar, then Java wants to find this kind of path to be able to reach this JSON package. So we can see what is packed into that jar archive by using the jar tf command with the name of the jar file. Now we have listed, for example, under this JSON com Google JSON path, there is all these things, and for example we are using the JSON package from that path, and it should be somewhere here, and the JSON builder, but it should also be somewhere around here. So this path is really important, and the way that we use this path like this is by including the exact path of that jar file inside our class path. Now I have used asterisk here. Asterisk means use every file under this directory, but if for example I have only one jar, then I can as well use this name. This is a bit counterintuitive. So until here, we were including only the paths, the directories as our paths. We didn't include a single file in this kind of paths until now, and this is the first time that we are actually naming a file. This is because this file is like an archive file, and inside there are other Java classes, so this is kind of treated as the top of this search tree. So if, for example, we use this one, then it's going to work, and I will also show how removing the name of this jar is going to make it unusable for us. So this is our Java file, and here I will go to source and I will try to compile this. The compilation is good now, but if I instead remove the name of this specific jar from here, I will also delete this part for now, so it doesn't stay from the previous setting, and I will, for example, copy this line here, and then I try to compile. Then I will have this. So this is a package doesn't exist and symbol cannot be found type of error. These are the types of errors that the Java compiler gives us. So the path to the jar file is not enough. We should either explicitly add the name of the jar file here, JSON something something, or you can add, for example, the asterisk, meaning all kinds of jars here. And typically I also add the legacy class path from before the setting to make sure I'm not missing something. Now we have compiled it. I think the compiled version is still here, but let's compile once more to show that we can now compile. Sorry, this will be the Java compiler. Yes, now we have compiled the Java file and created this class file. Now we can run this class using the command Java and the name of the class with no extensions. To be able to run this class, this JSON example.class, this must be available in the current working directory or the already looked files by Java, but since it is overwritten by our class path, it's important to also include here the current directory. Otherwise, the current directory is going to be skipped and Java won't be able to find it. If I didn't include this current directory here, okay, I'm going to take this line, copy it here, and remove this previous value of class path. Yeah, so let's try to run now. And this is going to give me an I couldn't find this class warning. If I have the current directory here at the end of class path, then it should be okay. So, two things that you need to remember about class path. One is in general to keep the current directory always somewhere here. The second is for jar files you need to include to the path of the file. Well, one third thing, for example, if you want to kind of install this class file now, the JSON class file that we have compiled to, for example, let's make a class directory up and move this JSON example class to that directory. And we want to set the class path up such that we can run this class from everywhere. So, for example, in this case, I won't be able to run it. Couldn't find because it's not here in my current directory anymore, but I can add this class to my class path. And I do this by adding all of these until the directory name. So here I don't specifically name the name of the file, which is JSON example.class, but I only describe it until the directory. Okay, let's check the contents of this class. I run my bash, then I should be able to run this Java executable from everywhere in my system. Yes. So this was one very simple example, in which case we went and we downloaded a jar file. We basically put it to somewhere that we know of, and we told Java runtime where it can find this jar file, and we wrote a very simple application that can use this jar file, and we well, basically we put our executable to a place so that we can run it from everywhere. We again described it in our class path. But if you if you want to install a library that's a bit more complex, then Apache provides a tool that's called Maven. That's a it's kind of a build automation tool. It is kind of similar to pip and conda again, in the sense that it handles dependencies for us. So for Maven, when programmers are providing us with some kind of Maven description file, then in it they write the dependencies necessary for that software, and then Maven can go and install these Java dependencies for you. So for example, let's have a look at this Apache OpenNLP library. This is a really extensive library provided by Apache, which has, for example, all sorts of useful tools that you can use, like this. This is a Java-based project. So let's try to install this one. And in this one, we are going to see a usage of Maven. First, if you are running on your own computer, we need to install Maven. If you are working in the university servers, you again don't need to worry about this. The servers have already Maven installed. And the way you can install Maven in the Linux computers is sudo apt-get install Maven and Maven 2. So there is a second Maven version. And for Mac, then you can use brew install Maven. I already have it installed myself. Okay. Then let's go back to the command line course, and let's download the source from OpenNLP. We are going to use a git command for this. You are going to see the details of this git command also in the other video this week. We are going to clone this OpenNLP directory. Once you have it, go to that OpenNLP and then run Maven, and we are going to run it with Maven compile first. Let's check, by the way, what kind of file Maven has here. So this pom.xml, this describes the dependencies that the project has, is provided by the authors of the NLP package, and basically it helps Maven to determine the dependencies and install them as well. So we are first going to do a Maven compile. As you can see, it's building different things, like this one here, and then another side tool, another side tool. So this is a really complicated big project. Apache OpenNLP has a lot of NLP tools. For this kind of complicated projects, it's really useful to follow the Maven installation if there is one. So now we are going to do a Maven install. It's running the tests to check if the compilation and installation went well. Once OpenNLP is installed, you can reach it via IDEs like Eclipse or NetBeans. You can use it to develop your code, but also this Apache OpenNLP, it provides a rather impressive command line interface. Now I will just going to show you this kind of interface, and I won't take too much of your time, but you can go inside and check what is available. I think it's a really impressive list here. Okay, finally. Once the OpenNLP is installed, now let's see what is here. We can run the command line interface by going to the OpenNLP tools and running bin OpenNLP. And this is going to give us this output, like in the documentation page. So it is basically run with OpenNLP tool, and for example, if I want to check one of the tools, then I can use this syntax. I'm missing the bin. Which is going to give me a demonstration of how it is used. So, this concludes our installation series. As you have noticed, installation is unfortunately quite a bit unique to the software that you are wanting to install. Well, in general, always check the software's README file. There can always be some kind of extra instructions for installation, but other than that, yeah, so this is how we install things in general for Python, C++, and Java software. Hope you enjoyed this part. So see you in the next videos.